Intelligent Transportation Systems Podcast. Hello, welcome everyone. Welcome back to the ITSPodcast. This is episode 37 for November 2016. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. Here we are again with the best periodical podcast on intelligent transportation, science and engineering. We have a very interesting menu for you today. We will talk about how intelligent vehicles field is evolving in the periphery of Europe, far from Daimler, BMW, Volvo and other huge car makers. We will talk about that with Professor Philippa Jimenez from Madrid. Of course, we also have a news mini-section by Dr. Marian Kaveshkar. She will tell us about a very interesting autonomous buses initiative up in cold and fascinating Finland. Don't miss it. Do you think you know all about automatic cruise control? Maybe you can learn a bit about the history of that convenient and fancy technology in another brilliant history mini-section by Professor Mehran Shirazi. Additionally, we will have another book review by Professor Haluk Erem about how transportation management can benefit from social media, a very hot and emerging topic in our field. And that's it! Get comfortable in your chair because we are starting now. Enjoy!
This is the news mini-section for episode 37, November 2016, by Mariam Kaveshkar. In the race of cities and countries adding autonomous driving vehicles, Finland is the last name to appear, including 2 autonomous driving buses to their already intelligent transportation system in Helsinki. The open roads of southern Hernesaari district was hosting the Easy Mile EZ10 electric minibuses for a month. After a month's successful trials, now they are on the roads in Nokia City, Espoo, sharing the road with normal traffic, where everything becomes more complicated with complex routes, stops and turns. The 2 French-made electric buses use vision, laser and differential GPS technologies to sense their surroundings. Even though the maximum speed of these buses is 40 km per hour, they travel at an average speed of 10 km per hour. They are self-driving and have no steering wheel. However, for this trial, there will always be an operator inside to monitor the journey. The project team is also building a virtual platform to test hardware and software integration outside the buses. The first scenario will be a traffic light control system in the pilot areas, with a platform later open for third parties to use. After Espoo, the automated buses will move to Tampere, central Finland, before winter arrives. The robot buses will return to the streets in the spring, with the pilots continuing until 2018. Helsinki has 2 more years to accomplish its 10-year plan to make car ownership pointless. Next step of testing the self-driving cars are set to take place on public roads of the UK, such as automated lorries on the M6, small public transport pods, and driverless Volvo SUVs in London. UK and Finland have become a cradle for developing and testing automated technology because Finnish and British laws do not require vehicles on public road to have a driver. These 2 European countries have not ratified the 1968 Vienna Convention on Road Traffic that stipulates a driver must be in the front seat of a car. Also, in September, the full US Federal Automated Vehicle Policy was published. It is available to download. It is about 116 pages, which you can go through it. That was all for this episode. Thank you.
Transportation in History by Mehran Shirazi, PhD candidate at Simon Fraser University, Canada. The origins of cruise control. The invention of the modern cruise control system is credited to Ralph Teeter, a man who couldn't actually drive due to being completely blind. A shop accident at the age of 5 took Teeter's sight away, but he quickly learned how to develop his other senses and tap into his passion for mechanics. Teeter was inspired to invent cruise control one day while riding with his lawyer. The lawyer would slow down while talking and speed up while listening. This rocking motion annoyed Teeter so much that he became determined to invent a speed control device. In 1948, after 10 years of tinkering, Ralph Teeter received his first patent on a speed control device. Early names for his invention included Autopilot, Control-matic, Touch-o-matic, Press-o-matic, and Speedostat, with Speedostat becoming the trademark name. Another decade and a few more patents were necessary until he could improve his original device to a version that could be installed on a commercial vehicle. The first cars to boast the new technology were the 1958 models of the Chrysler Imperial, New Yorker, and Windsor. They named it cruise control for the first time. In a couple of years, cruise control was a standard feature on all Cadillacs. Thanks to the oil crisis in the 70s and the savings in fuel that a cruise control system can have, it received a big boost in popularity. Today, cruise control systems are still evolving, including having more advanced self-driving features like automatic braking and adaptive cruise control. One of the engineers who worked with Ralph Teeter on the first cruise control device once asked him, "With all that you have been able to accomplish, what more do you think you would have done if you had been able to see?" Ralph replied with a smile, quote, "I probably couldn't have done as much, because I can concentrate, and you cannot," unquote. Well, at least the cruise control can concentrate for us.
This is the book review section for the present episode of ITSPodcast, read by Dr. Haluk Eren, Fırat University, Elazığ, Turkey. The book title is Best Practices for Transportation Agency Use of Social Media and consists of 312 pages, edited by Susan Brackman and Carrie Addison Watkins. It was produced by CRC Press in 2014. 7 chapters of the book consist of many ideas and practices of social media in transportation by eminent authors. Chapter 1 gives mainstream of the book. Chapter 2 mentions about existing social media platforms and their applications for transportation organizations. In Chapter 3, many interviews introduce social media practice of agencies and the lessons to be learned. Interviewees are from Akron Canton Regional Airport, District of Columbia, Washington State and Arizona, Central Ohio Transit Authority, and the Los Angeles County Metropolitan Transportation Authority. Chapter 4 comprises 4 sections. Firstly, marketing experts associated with transit agencies in Los Angeles, Dallas, and Denver elaborate the use of social media in marketing. Then, the other authors discuss social media use in organizations. After then, 2 authors from Los Angeles County Metropolitan Transportation Authority and from the Ohio State University discuss social media usage in public outreach and planning to get feedback from customers and drivers. The final portion of the chapter handles real-time communications via social media. Chapter 5 includes 3 sections related to social media for transportation organizations. 3 authors from CMU discuss social computing. The other 3 authors from Texas Transportation Institute and Georgia Tech talk about transportation organizations' use of social media to get involved in participants for market research surveys. The authors from Purdue University explain social media analytical tools for researchers and transportation agencies, with the aim of identifying service strengths and weaknesses and to assess customer sentiment. Chapter 6 contains 4 sections to help organizations in recognizing, understanding, and overcoming barriers and concerns. Here the authors discuss the resource requirements of maintaining a social media presence and policies to manage accounts and employee access, as well as archiving and records retention. The authors from Oregon State University and Georgia Tech discuss social media use of agencies to equitably provide information to citizens. Finally, Chapter 7 gives a summary of the book and provides guidance to transportation organizations who deserve to use social media. Readers interested in next-generation social media use of transportation will find many useful information in the book.
Hello again. Here we go with our main course today. Professor Jimenez coming from Madrid in Spain. Have fun. Hello, we are today with Professor Philippa Jimenez from the Technical University of Madrid in Spain. He is also head of the ADAS System Unit at the University Institute of Automobile Research. His scientific interests are very focused on intelligent vehicles, in particular ranging from active safety, automatic control to vehicle modeling. Hello, Professor Jimenez. Can you please introduce yourself and your center to our listeners?
Hello. Well, as you have said, I'm professor in the mechanical engineering at the Technical University of Madrid, and I'm also leading the group of the Intelligent Systems Unit at the University Institute for Automobile Research, that is also belongs to the same university. We are working in ADAS systems and also in autonomous vehicles and intervehicular communications and things like that.
Professor, you're leading a networking action there in Spain on intelligent vehicles called RITEVI, which means Intelligent Vehicles Excellence Network. Is that right? Can you please talk about it?
Yes, you're right. RITEVI network is a network that it was funded by the Spanish government. We started our activities 9 months ago, approximately. And the main groups that are working on intelligent vehicles and intelligent transport systems in Spain are here involved. What we have tried is to involve all the partners that could be interested in these topics and have been doing advances in the last years. And also, very important characteristic of this network is that there are groups that work in very different areas within the intelligent vehicles. For example, we have groups that are experts in computer vision, in laser scanner detection, in autonomous vehicles, in wireless communications, and sensors, actuators, and so on. So I think that we have managed a very complete group of experts, and well, I hope that we'll have good results in these 2 years that we are going to work together.
Professor, can you talk about how is the intelligent vehicles field developing in Spain? We have heard a lot of amazing progress that is being happening in Europe, like in Germany, France, or Sweden, to name a few. But how about Spain? Can you please tell us how's that part of Europe contributing?
In Spain, of course, we have very good research teams. Perhaps they are not so famous as some of the European ones in France or Germany and United Kingdom, but it is true that some of them are involved in very important and huge European projects together with the leading partners of these areas. They are taking advantage of all the expertise that they have been taking along the years, and well, I think that the main leaders of these areas have confidence in our groups. From my point of view, the clear proof of these situations is that they are still involved in European consortiums and in many discussion forums in Europe and worldwide, and well, this is the clear proof that they have a quite high level in research and innovations in these fields of intelligent vehicles.
Okay, Professor, as an expert in the field, what do you think is the main challenge ahead regarding intelligent vehicles development? What is the next big problem to solve? Is it a technical challenge, for example, about perception, prediction, the intentions prediction, or is it more on the lawmakers and insurance companies' sides of the road? What do you think?
Well, I think that everything is important. From my point of view, it's a technical point of view. I think that there are many things that have to be solved. For example, when talking about autonomous vehicles, the highest levels of automation, such as levels 4 and 5, many things have to be solved, detections, algorithms, decision algorithms in order to decide which is the best maneuver at every moment, progress in how to react when something strange happens around the vehicles. These kinds of things should be solved. When talking about wireless communications, we have to think about the correct technology for these communications, how to manage all the information that we are going to retrieve, and how can we manage and filter those information, those data that perhaps some of them are wrong, some of them are incomplete, some of them are true, and we have to decide which of them are really true and right, and we can use them. So from the technical point of view, there are many things to do. This is a very good thing for us, of course. On the other hand, there are legal issues. From the legal issues, we have to take into account that the way of driving in the future would be different as we do now and we have been doing for the last decades. If automatic functions are involved in the vehicles, are included in the vehicles, legal issues should take this into account because responsibility of drivers and vehicles should change. Of course, there are also something very important about social acceptance. We have to think that we cannot introduce any systems in the market if the people do not accept those systems. So we have to be aware of what people want and what they could accept and what they are not going to be accepted by them. So, well, as you can see, there are many things to take into account, and it's quite difficult to know which is going to be the bottleneck in the future. If the bottleneck would be the technical, legal, social, economic issues, it's difficult to say now. From my point of view, what we have to do is to go step by step and see what it's happening. It's the best way to advance.
Mm-hmm. Okay. Hi again. We are recruiting volunteers for the ITS podcast. If you like our show and you think you can share some of your time with us, please let us know. Send us an email to ITSSpodcast@gmail.com. ITSSPODCAST@gmail.com. Also, it would be great if you could subscribe to our social media like Facebook, LinkedIn, YouTube, and more. You can find links to all of our social accounts at ITSP.CICEI.com. Thank you. Let's get now back to our today's main course. Professor, it is well known that Spain has suffered a lot during the last years because of the global financial and economic crisis. From your point of view, has it affected negatively the work of scientists and engineers working on ITS in Spain? Are there any green sprouts there of improvement?
Well, of course, economic crisis has influences negatively in our groups because of the reduction in funding, mainly in public fundings. The main consequence of this crisis would be that some of the groups have decreased their volume of people, and researchers are difficult to maintain in our groups. The positive thing is that many of the groups, and the most important ones, have survived this crisis. They have tried to obtain new knowledge. They have been exploring new ways to obtain this knowledge and more capacities in order to grow in these adverse conditions. It is always said that a crisis is not a negative thing, but an opportunity for groups to grow. And I think that some of the groups, the main groups, have taken advantage of these situations. And now that we are coming out of this economic crisis, I think that we are stronger and we can manage the main topics that we have to deal with now at the European level.
Right, that's great news. Professor, let's end up this brief interview with a classical question in this show. Professor, about the future intelligent automotion, do you foresee a future with only automated vehicles to cancel the human influence on incidents and fatalities in the roads? Or will it be, for most of the scenarios, more and more sophisticated ADAS developments, but always with a human on the top supervising? What do you think?
Well, this is a quite controversial question, and it's difficult to explain and to give a specific answer. From my point of view, it depends on the time interval we are talking about. Perhaps we can see in the research field that many advances have been done in the last years in the field of autonomous vehicles. The thing is that there is a gap between what we have done in research and what can be put in the market for every user. And how can we manage with all these autonomous vehicles and automatic functions in the real world? As I have said before, I think that the best thing is to go step by step and start with quite light automatic functions to see what happens, which technical problems can we see, how is the acceptance of people. And then from this starting point, we can go further and look for more automation levels and, well, study what is happening. Of course, it's it's difficult because, as I have said before, there are many factors that are influencing in this introduction of autonomous vehicles. So it's difficult to have a clear expectations of what is going to happen. So I think that the key answer is to go step by step and analyze each step, and then with conclusions we obtain, go further.
I'm sure that you heard of that recent fatal accident of Tesla's vehicle, right? Is it telling us something? Are we over-optimistic in this field?
Well, from my point of view, there are two clear messages. The first one is that automation would lead to a reduction of traffic accidents, but automation will not remove or eliminate completely those accidents. Some accidents would happen even when all vehicles are autonomous because, well, there are some elements that they cannot cope with them. Apart from that, there is another important message is that we have to be aware of the capabilities of the automatic functions. And drivers should know that at the moment they should supervise what the vehicle is doing all the time. So although the vehicle can do many things without our actions, we should supervise what it is doing, no? So we have to take that into account, and we don't have to rely on automatic functions that perhaps there is something that we have to supervise and to see what it is doing, because some failures are also possible. From the technical point of view, there are many things that are quite well proven, but perhaps in specific situations there could be false negatives or false positives, and well, this uncertainty should be solved by the supervision of the driver. This is, I think, that the second message that we can take from that accident.
Well, that's interesting. Okay, that's it. Thank you very much for your participation. I think our listeners will enjoy and learn a lot from your interview. Goodbye, Professor, and thanks again.
Okay, goodbye. Thanks.
Okay, this is the end of today's episode. But we are already working on the next. Anyway, if you feel like it was too short, please check out our previous episodes at itspodcast.com. We have another 36 very interesting episodes ready for your ears. And you could even help us a lot by posting your comments or disseminating them. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain, soundtrack developed by Rubicon, audio edition and post-production by the Institute of Cybernetics at the University of Las Palmas de Gran Canaria. I'm Javier Sanchez Medina from the IEEE ITS Society. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.